Hi students, welcome back to our class. For today's lesson, we have lesson number 1, which is relations and functions. A relation is a set of ordered pairs. Set of 2, 3, negative 1, 5, 4, negative 2, 9, 9, 0, negative 6. This is a relation. The domain is the set of all x values in the relation. The domain is equal to the set of negative 1, 0, 2, 4, and 9. These are the x values written in a set from smallest to largest. The other one is called the range. The range is the set of all y values in the relation. Range is equal to the set of negative 6, negative 2, 3, 5, and 9. These are the y values written in a set from smallest to largest. A relation assigns the x with y's. On the right hand, we have the range, which is the sets of all y's. On the left hand, we have the domain, which is the sets of all x. 1, 6, 2, 2, 3, 4, 4, 8, and 5, 10. This relation can be written in the set of 1, 6, 2, 2, 3, 4, 4, 8, 5, 10. A function f from set A to set B is a rule of correspondence that assigns to each element x in the set A exactly one element y in the set B. Set A is our domain and set B is our range. The function has two conditions. The first condition is each element x, meaning must use all the x. The other condition is exactly one element y, meaning the x value can only be assigned to one y. Let's have example again. 1, 4, 4, 8, 2, 2, 5, 6, and 3, 10. In this given, you will notice that all x are assigned. Then the first condition in this given is correct. And the second condition says no x has more than one y. And it also meets our condition. Since the two condition is met, then we can conclude that this is a function. Let's look at another relation and decide if it is a function. Set A again is the domain and set B is the range. 1, 4, 4, 4, 2, 4, 5, 4, and 3, 4. The first condition here is correct because we assigned all the x. The second condition is also correct in this one because no x has more than one y assigned. Then, since the two condition is met, then we can conclude that it is a function. The second condition says each x can only have one y, but it can be the same y as another x gets assigned to it. A good example that you can relate to is the student in our math class this semester, our set A. So the green one is our domain or our set A. So these are the students. The grade they earn out on the class is set B. In this given, set B is our grade and that is our range. Each student must be assigned a grade and can only be assigned one grade, but more than one student can get the same grade. We hope so. We want lots of A. The example shows on the previous screen had each student getting the same grade. That's okay. Student 1 get 2, student 2 get 10, student 3 get 8, student 4 get 6, and student 5 get 4. Student 2 get 4 again. Is this relation shown above is a function? The answer here is no. Why not? It says that can only be assigned to one grade, But by looking at student number 2, it assigned with 2 grades, which is 4 and 10. So that means since student 2 get 2 grades, then this is not a function. Let's check another relation and determine if it is a function. Set A again is the domain and set B is the range. 1, 6, 4, 4, 2, 2, and 5, 10. It is not 3 didn't get assigned to anything. Compared to our example, a student in math must receive a grade. So, the first condition is must use all the x is not met in the given. That means we can conclude that this is not a function. Another example. Check this relation out to determine if it is a function. Set A is the domain and set B is the range. 3, 2, 1, 6, 4, 4, 2, 2, and 5, 10. This example is fine. Each student gets only 1 grade, so all x are used in this given. More than one can get an A. And I don't have to give any this. So all y's don't need to be used. So in the given, x must not be repeated and y can be repeated. Since the two condition is met in this example, then we can conclude that this is a function. Let's determine whether each relation is a function. 2, 3, 3, 0, 5, 2, and 4, 3. The answer here is yes, because every domain is different. If you will look for the domain, that is on the left side. 2, 3, 5, and 4. Another one, 4, 1, 5, 2, 5, 3, 6, 6, and 1, 9. This is not a function because 5 is paired with 2 numbers. That means the domain is repeated in this example, which is 5. Another example, set of 1, 3, 2, 3, 3, 3. Is this relation a function? The answer is yes. Even they have the same range, but by looking at its domain, no domain are repeated in this example. Let's proceed with the vertical line test. If it is possible for a vertical line to intersect a graph at more than one point, then the graph is not the graph of a function. I'm going to show you a series of graphs. Determine whether or not these graphs are functions. You do not need to draw the graphs in your notes. Number 1. Is it a function? The answer here is yes because there is no x repeated in the given. Number 2. Is this a function? The answer here again is yes because again there is no x repeated in the given graph. Number 3. Is this a function? No, because in this given, there is repeated x in the given graph. Here and here, the other one is here and here, and also in these points, they have the same x. Number 4, is this a function? Yes, this is a function because there is no repeated x. Number 5, is it a function? No, okay, because x is repeated in this example. Like here, in these points, x is being repeated, repeated, and repeated. Number 6, is this a function? Okay, yes, this is a function. Number 7, is this a function? The answer here is no, because they have the same x or same domain. Number 8, is this a function? The answer here is also no. In this example, we can say that this is a function, but if you will look at this line and this line, we can say that it is not a function because it has the same domain or x value. Number 9, is this a function? Yes, every domain here is different. Number 10, is this a function? Okay, the answer here is yes. I hope you learned something today. See you again on next topic. Goodbye. Thank you for listening. God bless.